Welcome back, everyone. I hope you are well and safe there at home. Let's go straight to what I want us to look at today. We are going to be looking at area of triangles, and our objective for today's lesson is to calculate the area of oblique triangles. But let's understand, first of all, what is oblique triangles? What do we mean by oblique triangles? We have a right angled triangle. We know it's a right angled triangle, right? But then we have a triangle like this where we have an angle which is more than 90. One angle which is more than 90. And we have a triangle here where all of them are less than 90. All of them are less than 90. All of them are less than 90. So this one is an obtuse triangle because we've got one angle that is more than 90. I'll say obtuse triangle, and this one is acute triangle, and that's a right angled triangle. Now, looking at the area of triangles, we know how to find the area of a triangle. The area of a triangle is half base multiplied by height. So I'll introduce to you, I'm going to show you two methods. One method is if we know what the side A, B, and C are. We know what side A, we know what side B, and we know what side C are. So this one, if we know all the sides, is called Heron's formula. And Heron's formula says you have to, area would be the square root of S. This S is the semi-perimeter. So S minus A, remember that's the A, the B, and the C, into S minus B into S minus C. And you square root this and you find your answer. Simply as that. But how do you find your S? Your S is A plus B plus C divided by 2. So that's how you find your S, and you put everything into your calculator and you find your area. So that's Heron's formula. It's easy, just like that. Now I want us to look at the second one. The second one we're going to look at is area rule. Okay? Now, the first situation, we have all the sides. The second situation is if you are given a triangle like that, and that's angle A, angle B, angle C, and you know that opposite your angle is small a to represent the side, opposite the angle B is small b to represent the sides, and opposite C is angle side C to represent the side. Okay? Now, in a triangle like that, I do not know what the height is. I don't know what the height is. And remember, we said half base times height. I know what the base is, but I don't know what the height is. What am I going to do in such a situation? So here, I know that I need the height. I need the height. So I'm going to create my own height, which is a perpendicular height. And that is my height. So here we want to formulate a rule that is going to help us to calculate the area of an oblique triangle, but we don't have the height. Okay? So in this case, let's put an angle there. And we call that theta. And you will see that here now, I have myself a right angled triangle. I have myself a right angled triangle. And I have the angle, I have the hypotenuse of this triangle. I'm talking about this triangle, and I have the height. let's talk about these three right now. What is the relationship that these three gives us? This is opposite, the angle, and that's the hypotenuse of this triangle. So we see that we've got hypotenuse, we've got the opposite of this, which is your h, and your hypotenuse. So, and your theta there. So we can say sine theta is equal to opposite over, which is h over a. Do you agree that in this triangle, this h is opposite your angle, and this is hypotenuse of this triangle, right? So now, what would your height be here? Let's rearrange your h, therefore there will be your a sine theta. So now I know what my height is. I'm happy. I know what my height is. Now I can, so that means the area here, remember it was half base times height. Times height. What is your base? My base here is b. B. What is my height? My height is a sine theta. So I have my formula, and I just rearrange that as AB sine theta. Okay, so that means if I know what this side is, now you see I've incorporated side B, I've incorporated side A, and the angle is in between. So that means you can find the area of any triangle in which you know the side, say that is 5, and that is 8, and that is 40 degrees. So you see the two sides are here and the angle is in between. Always the angle is in between. So I can calculate, because here this, in formulating this, I have my B, I have my A, and the angle is in between. Yeah? So as long as you have your sides and your angle in between, so you can use this formula. So what will the area of this triangle be? The area would be half times side A, 8, multiplied by 5, multiplied by sine what? Sine 40. And whatever angle, the answer you get there will be your area. So that's it. That's we've formulated this area. We've derived the area rule there. So we can use it now to calculate a triangle like this. We can use it to calculate a triangle like this, and we can use it to calculate a triangle like this. And you see that here I have the two sides and the angle in between. What are we going to do here? What is it that we know? If these sides are the same, what does it say about the angles? Okay, and here as well, we know that side, right? But what knowledge are we going to apply here to find the area of the whole parallelogram? But then the last one, which is very nice, is a question that we once dealt with before we closed, which is the area of the segment. But I'll give you a hint on this one. Remember the area of a sector. Now you know how to calculate the area of this triangle, and you know how to calculate the area of the sector. So how will you find the area of a segment? So I'll leave it here. The first thing that I want to see on your assignments is the examples A, B, C, and D. Then after that, you are going to do 18, exercise 18.3 and 18.4. So this is what you have to do for your homework. Thank you.